Hey Matthew B, this is Mr. Roberts. I know that most of these are probably pretty straightforward problems for you. I just wanted to give you a couple quick reminders, just in case you're a little confused. Um, I guess we'll look at number 4 here. The first four are pretty much the same. We have to find the missing side of a right triangle. Given that they are right triangles, the Pythagorean theorem definitely applies. And the first thing I do is I just identify the two legs of my right triangle. I have a leg here and a leg here. And this side is the hypotenuse. And the Pythagorean theorem tells me that if I take a leg and I square it, and I add to that the other leg squared, I will get my hypotenuse squared. Now you'll notice it is the square root of 170, and as soon as you square that, you end up getting 170. So that's nice. Over here we have x squared plus 49. If I take away 49 from both sides, at this point, you know what? It's arithmetic. You guys can figure this out. But definitely take away 49 from 170, and then we would take the square root to figure out what x is. That equation actually has two answers. There's a plus and a minus value, but only the positive one makes sense in this context. For the next group of problems, you're asked to find the missing side of some right triangles. But you'll notice you're only given information about one of the sides, not three of the sides. So here we're going to be using our trig ratios. You'll remember that every right triangle, if I'm speaking about this angle, it matters what angle I'm at. From this angle, I have an opposite leg. I have a hypotenuse. I'm sorry, I have an adjacent leg. Just kidding. ADJ leg. And over here, I've got the hypotenuse. And my three trig ratios are sine, cosine, and tangent. And for convenience, I'm going to call this angle theta. So the sine of angle theta is opposite leg divided by the hypotenuse. The cosine of theta is the adjacent leg divided by the hypotenuse. And the tangent of theta is the opposite leg divided by the adjacent leg. So, you know, if you don't have that in front of you, you might want to jot that down. Make sure you remember that. And the beauty is you can rewind it if you need to go back and look at it. But if we look at number 7, this is my angle. And from this angle, I can see across from it is the opposite leg. This is the adjacent leg. And right here, across from the right angle, is the hypotenuse. I have information about the adjacent leg, and I'm asked to find the hypotenuse. So I'm definitely going to use my cosine ratio. So the cosine of that 38-degree angle is equal to the adjacent leg, 15, divided by the hypotenuse, x. This is one of those situations where my variable is locked up in a denominator. My preference is always to multiply both sides of that equation by x. Notice x over 1 really is just x. I've written it that way so that we can clearly see that there's a common factor here. I have an x in this numerator and the denominator. Those will cancel. So over on the right-hand side, we're left with just 15. And on the left-hand side, we have x times the cosine of 38. And finally, to solve for x, I'm going to divide both sides of this by the cosine of 38. So I write x is equal to 15 divided by the cosine of 38.